Well, just to remind you how to do the kinematics calculations that we've been doing up till this point. First of all, I'm going to remind you of the equations we've been using. For horizontal motion, and sometimes my iPad screen freezes. Here we go, horizontal motion. We have four equations, and they are x over t equals v sub 0 plus v over 2. V equals v sub 0 plus at. The third equation is y, let me try that again, x equals v sub 0 t plus 1/2 at squared. And our final equation, v squared equals v sub 0 squared plus 2ax. So those are the equations that we used for horizontal motion. Now for vertical motion, otherwise known as free fall, clean that up just a bit. And vertical motion is also called free fall. The four equations are the same equations, but they are slightly different because we're moving in the vertical direction. Also, we know that the objects engaged in free fall have an acceleration which we already know, which is 9.8 meters per second. We use the symbol g to represent 9.8 meters per second squared. So our four equations become y over t is equal to v sub 0 plus v over 2. The second equation is v equals v sub 0 minus gt. And what that means is that we know that the acceleration g is directed downwards, and consequently we put a minus sign there. Our third equation becomes y equals v sub 0 t minus 1/2 gt squared. And our final equation is v squared is equal to v sub 0 squared minus 2gy. So you can see that these four equations, they're really the same four equations all over again. It's just that we adjusted them just a bit to represent vertical motion under the influence of gravity. So let's consider an example. Okay, let's say that we have an object that's traveling horizontally. So we'll abbreviate that HORIZ. And we'll say that its initial speed is 10 meters per second. The distance that it travels, excuse me while my screen unfreezes. Okay, the distance it travels, let's say, is 25 meters. It's 25 meters, and we'll say that the amount of time over which it moves is 10 seconds. So what we want to do, we want to figure out the two other remaining kinematic quantities. In those equations, there are 5 kinematic quantities. So far we've got 3 of them, v sub 0, x, and t. So the two remaining are v and a. So those are the quantities that we want to calculate. So the recommendation I give you for this is that we set up our system of boxes. And there are going to be 5 of them. X, v sub 0, v, a, and t. So for our particular problem, we know that x is 25. We know that v sub 0 is 10. We don't know what v is. We don't know what a is. but we know that t is 10. Okay, so all right, so let's calculate what v is first. So if we're going to calculate what v is first, then that means that for the moment we don't need to know what the acceleration is. So since we don't need to know what the acceleration is, we're going to go back to our 4 horizontal equations, and we're going to find the one that does not contain a. So of these 4 equations for the horizontal, the one we're going to use is this one that I've just circled. So I'm going to eliminate that. What I'm going to do is I'm going to copy that equation, and we're going to go to the next page. So here we are using that equation. And what we're going to do is we're going to replace the symbols by the numbers that were given in our box system here. Now, first of all, we notice that x is 25, that t is 10, and v sub 0 is 10. So x is 25 over t, which is 10, is equal to v sub 0, which is 10 plus v over 2. And so that means that we don't know what v is. So one thing that we can do is we can multiply both sides of the equation by 2. If we do that, we're going to multiply by 2 over 1 on the left side of the equation, and we're going to multiply by 2 over 1 on the right side of the equation. So on the right side of the equation, the 2's over here cancel, which is why we do this. So on the right side of our equation, we get 10 plus v, because the 2's canceled. On the right side of the equation, if we multiply this out, we get 50 over 10. And then if we reduce 50 over 10, we can reduce that to 5 equals 10 plus v. And then I'm going to subtract 10 from both sides of the equation, which gives me negative 5 is equal to v, or in other words, that v is equal to negative 5 meters per second. So what that means is that this object had been traveling at 10 meters per second to the right. It slowed down, came to a stop in between, changed direction, and started traveling to the left at 5 meters per second. Okay, so we now have solved for v, and that was one of the 2 things that we set out to find. Okay, now the other thing we're going to find, if we go back to our system of boxes, okay, we now know that v is 5, so we figured that one out. So we can put that in our system of boxes, and we know that that's 5. And so now we want to calculate what a is. And that would be this box here. Okay, so to do this, now we don't necessarily want to use the number that we just calculated, which was for v. So we're going to use the equation that does not have v in it. And if we look at these 4 equations, the first equation has v and v sub 0. The second equation has v and v sub 0. The fourth equation has v and v sub 0. But the third equation only has v sub 0 and not v. So that's the one that we're going to use. And my screen is frozen again. So I'm just going to go to the next slide and write down that equation. X is equal to v sub 0 times t plus 1/2 at squared. And we will insert our numbers. Now we know that x is 25. We know that v sub 0 is 10. We also know that t is 10. We don't know what a is, but we know again that t is 10. So we get 25 is equal to 100 plus, now 10 squared is 100. 100 times 1/2 is 50. So this becomes 50a. Now at this point we're going to subtract 100 from both sides of the equation, and we'll get negative 75 is equal to 50 times a. Let's switch the sides. 50a is equal to negative 75. We can do that. That makes perfect sense. No reason why we can't do that. And then we're going to divide both sides of the equation by 50. And so we get a equals negative 75 over 50. Or in other words, a is equal to negative 3 over 2 meters per second squared. That's because 25 goes into 75 3 times, and 25 goes into 50 twice. So we have solved for both the acceleration and for the final velocity. So that's how we use those equations. Now let's use the vertical motion equations. We'll say that let's write out a problem. And that's not the device I wanted. So let's say an object is dropped from rest from a height of 100 meters. Okay, so we can find two things. Okay, one is let me try to write that again. What is the speed of the object just before it strikes the ground? Okay, and then the second part of this is how much time does it take the object to fall? Okay, so so we know the object is dropped from rest, it says. And that word rest is a magic physics word, which means that the starting speed of the object is 0. So starting from rest means that it's stationary, it's not moving, and its speed is 0. So that in this case means that v sub 0 for this object is 0. And then we see that it's falling from a height of 100 meters. So we know that the object is going to fall, or in other words drop, a distance of 100 meters. So let's set up our chart. Whoops. There we go, and we have y, v sub 0, v, the acceleration, and t. Now we know that the distance it falls is 100 meters, so since it's falling, we're going to say that that's negative 100. V sub 0, since it's starting from rest, is 0. And we happen to know that the acceleration is g. And g is 9.8 meters per second squared. So we need to calculate, first of all, how much time it takes, or rather how fast is it traveling at the instant that it is about to touch the ground, and that's v. And then the other thing we're going to calculate is how much time it takes, but we're not going to need that first. So we have three quantities, y, v sub 0, and a, but we need to find v. And we want to use the equation that doesn't have t. Now that equation is the fourth equation, which says that v squared is equal to v sub 0 squared minus 2gy. So let's put our numbers in. We don't know what v is yet, so we'll continue with v squared. V sub 0 is 0, so we have 0 squared minus 2 times g. We just said that g is 9.8, and y is negative 100. Okay, so we get v squared, and we can ignore 0 squared. The other thing that we notice is that we have minus 2, but we're also multiplying by a negative 100. So we have negative 2 times 9.8 times negative 100. So I'm going to multiply 2 times 9.8 times 100, and that gives us 1,960. So then to get our answer, we're going to take the square root, and we'll get the square root of this is 44.27 meters per second. However, we're going to say that it's negative because we know that the object is falling. So that is the answer to that first question. Okay, we know that the object just at the moment that it's about to hit the ground is traveling at 44.27 meters per second, and it's falling downward. Okay, so we just figured out what goes in this box. And my screen is frozen again. Okay, so we just found out what goes in that box. So that means that we can erase that. And now we want to figure out what's going to go here. Okay, and now for this one, we could use the third equation. However, using the third equation leads to a quadratic equation to be solved, and I prefer to avoid those. So in this case, we are going to use this answer that we got for v. Usually we wouldn't want to do that, but I'm going to do that in order to avoid having to do a quadratic formula. So instead, we're going to use the second equation, which is v equals v sub 0 minus gt. And we'll plug our numbers in. We just found v is equal to negative 44.27. We know that v sub 0 is 0. And then we have minus gt. G is negative 9.8. But we don't know what t is. So now this turns into negative 44.27 is equal to negative 9.8 times t. If we swap sides, we can get 9.8t is equal to 44.27. Then we divide both sides of the equation by 9.8. So t is going to be 44.27 divided by 9.8 meters per second squared. And then that's going to give us t equals, and we'll use our calculator here, 44.27 divided by 9.8. And that gives us we'll call it 4.52 seconds. Nope. So there we go. We got our answer for part B, which was the amount of time that it takes the object to fall from a height of 100 meters. Okay, so that's it. That's how you do these problems. Hopefully this refresher video helps you to clear this up and understand this better.